Hey all, today we're going to continue talking about proportions in triangles, and now we're going to talk about how they interact with similar triangles. And so just a bit of notation to start. Back when we talked about congruent triangles, we had this symbol, or whenever we talked about congruent things, we had that symbol, the equal sign with the little squiggly on top. Well, let's add in a new symbol for similar, and that is just the squiggly. This is something we used way back in the beginning of the year when we talked about logic. This meant not, but in this context, when we're talking about triangles, or really any sort of polygon, but we'll talk about triangles, this symbol means similar. So if we come down here, and I'm actually going to start with this problem labeled number 2 first, because it has this triangle similarity statement. It's saying these two triangles are similar. I'm actually not going to leave that there. I don't want it to look like congruent. They're similar. They're not congruent, which means they're not going to be the same size. But what we know about them are two different things. So when we had congruent triangles, we knew that the corresponding angles were congruent and the corresponding sides were congruent. And so therefore the two triangles were the exact same size. In this case, they're not. You can see that one triangle is bigger. I would say triangle JKL is bigger. What we know about similar triangles is that the corresponding angles, I'll use the angle symbol, they are congruent. So that's the same as when we had congruent triangles. The corresponding angles are still going to be congruent. So as you can see here, J and J should correspond because of the names. They're first in the names. And you can see down here that J and J have two arcs, meaning they're congruent. And so that means that K and D, the two middle letters, I'll put one arc. They're going to be congruent, the same size. That's not a change. L and C will be congruent. We'll put 3 marks. So this idea is the same as when we had congruent triangles. The corresponding angles will be congruent. The thing that changes are the sides. So this is sort of what makes similar triangles similar and not congruent. So the corresponding sides are in proportion. So when we talked about congruent triangles, we would find the corresponding sides and say that they were equal. They would be the same side length. This time we're going to find the corresponding sides and we are going to write fractions with them. So I am going to take this side that is 36 long, JK, that's my first two letters, and I'm going to write a fraction. I'm going to find its corresponding side in the other triangle, the first two letters, JD, that's over here, it's 12. So there's one fraction. So rather than say they're equal, because they're corresponding, I'm going to write them as a fraction. I want to know how long JL is. JL is my first and third letter. So I'm going to go down here. I'm going to find my first and third letter, JC. That's 10. And I can write that as a fraction. These triangles are similar, so that means those fractions I created using the corresponding sides, those fractions are going to be equal. Now, if I knew KL and CD, I could say that that fraction is equal to these two, but I don't have any information for those. And as you can see, hopefully, is that we have a proportion to solve like we have in the last couple lessons. And we can solve them the same way. Cross multiply 12 times question mark, 36 times 10. And then we can go ahead and divide both sides by 12 and get question mark to be 30. And so that means this side is 30. And since this is the bigger triangle, it would make sense that this side 30 is bigger than 10, much like this side 36 was bigger than 12. And so that's one way you can check to see if your answer makes sense. So let me recap when we have triangles that are similar, we know they're similar because of this symbol, the little squiggly. The corresponding angles are going to be congruent. They are going to be the same size. The corresponding sides are not going to be the same size. We are going to take the corresponding sides and we are going to write them as fractions. And if you notice, the top number in both of my fractions came from the same triangle. It came from this triangle, the big one. The bottom number in both of my fractions came from the same triangle, this one down here, the smaller one. It's potentially that you could write the smaller numbers on top of the fractions and the bigger numbers on the bottom. That's totally fine. You could still get the same answer. You just need to make sure you maintain consistency. So the numbers from one triangle go in the same place on top or on bottom. I'm going to come back to this one in a minute because I want to do a couple more where I have similarity statements. So again, we can match up the corresponding sides by looking at the names. And I'm going to tend to start with the side that has X or question mark. You don't have to. That's just sort of the way I tend to do things. And so that is side VT. That's the first and third letter in this first triangle. And so that should match with VM. VM is this one. So there's my first fraction. And since the top of this fraction came from this triangle over here, I should pick 77 because it comes from that triangle and put it on top. That's VU. That's my first two letters. So it matches VL, which is 35. And now I can cross multiply. I can do 35 times 6x minus 5. And I'm going to write that out. And then 25 times 77. And I think until you become a real expert at this, it's good to take this step and show your work. And I even find it good for myself to keep myself organized so that I know that I need to do 35 times 6x and 35 times negative 5. And these are big numbers. That's okay. Once we get to the end of this, we'll have a number that is reasonable for this, this value of x. I'll move 175 over here and it'll become positive. And so I'll get 1925 plus 175. And then I'm going to divide both sides by 210 to get x to be 10. There we go. We're back to sort of a reasonable number. So we're using these similarity statements to match up which sides correspond, and then we're writing fractions using those corresponding sides. And of course, the top two numbers here came from the same triangle. The bottom two numbers came from the same triangle. And you just want to maintain that consistency. So now let's go back up here, and we don't have similarity statements, but this is sort of where we can go based on logic. I'm looking for this side, question mark, and I'll put that on top of my first fraction. And you might guess that it corresponds, this question mark is this side in the big triangle, and then we have a smaller triangle right here, this small triangle, and you might guess that question mark corresponds to this side. They're on the same side of the picture. And then we have 70. That's this big piece, and it goes with 42. And you can see that question mark and 70 come from the same triangle. They're both on top. 27 and 42 come from that smaller triangle. They're both on the bottom. Now we can solve this proportion, and I hope you're getting really comfortable solving proportions with all of the proportion solving we're doing. I'm going to divide both sides by 42 and get my missing piece. So I did have an extra one here. I'm not going to solve this completely, but I will set up the fractions just as one more example. I'm going to start, as I suggested, with the thing I'm looking for, 5x on the top of my first fraction. That's just the way I tend to start. It's a starting off point. You start the same way every time. That gives you somewhere to begin. That's GF. That's my first two letters, so I'm going to go match it with ST or TS. That's this piece. And then I have this other side, GH. That's going to go on top because 5x was on top and they come from the same triangle. GH goes with TU, which we have, is 30. And so we could cross multiply here and solve this, but right now I want to focus on getting those two fractions. This is the new piece. So as ever, if you have questions before you do the U-Try problems, please do ask the questions. If you feel ready and prepared and confident going forward, you should try these two and then check your answer. So check your answers here. If you got one or both of them wrong, or maybe you got the proportion set up wrong and then you think you did the solving correctly, please do ask for help so we can see where the problem might have happened. In this first problem, we have all the sides labeled. So this fraction on the right could either be 12 over 9 or 28 over 21. Both of those fractions would work because all three pairs of corresponding sides make fractions that are equal to each other. So as ever, we have practice for you. Please do take your time on these. Ask questions when you get stuck, and good luck. I'm going to make this a little smaller.